Our first appearance is, I'm in a green, pleasant, rural environment, but you may hear some noise. Right now, I'm in a noisy, bustling city, the biggest city in Europe, London. But like any major city, it faces some serious issues. And what is the cause of those issues? Climate change. Now, what does climate change mean for cities? Well, first of all, flooding. That's a particularly severe risk for London. Secondly, heat waves. We have to be alert to the dangers that climate change poses. So what can we do? Now, we can use conventional technologies to help address these problems. Or there is an alternative, nature. What do I mean by nature? Well, if you see where I am right now, I am on a green roof. Yes, I am not on the ground. I am 5 stories up on one of the halls of residences at Imperial College, London. So behind me is a high-tech weather station. Now, you don't normally need this for a green roof, but Imperial College, for the Climate KIC Blue-Green Dream project, we are actually measuring what the benefits of a green roof are in terms of its ability to absorb stormwater and its ability to improve the energy efficiency of your building. But to start off, the question I want to pose to you is, why should we have green roofs, and how can it help to protect our cities against climate change? So right now, I'm looking at a collection of plants, and these plants are growing on a modern engineered green roof. But this isn't the first green roof. In fact, people have been using green roofs for over 3,000 years. And why did they use them 3,000 years ago during the Bronze Age? Well, they were used mainly in Northern Europe, especially Scandinavia. And why did the Scandinavians appreciate these green roofs? Because of their thermal insulating properties. Of course, it gets very cold in the far north, but a turf roof, a green roof, is hugely effective at trapping the energy within a building. Now, in the present day, is that something we should be interested in? Absolutely. In the UK, 60% of the energy used in the domestic home is utilised for heating purposes. And what's the easiest way to insulate your roof? Well, add a green roof. So why have a green roof now? First of all, climate change. What does climate change mean? Well, if you live in a city, the biggest risk it poses at the moment, especially in London, is flooding. As you can see, we have a little bit of rain here at the moment in London. Not unusual here, but the big threat we face with climate change is the increase in the number of extreme weather events, especially storms and intense rainfall events that can overwhelm our drainage system. Now, why would our drainage system get overwhelmed? Well, the big reason is because so much of our cities are covered with impermeable surfaces. What do I mean by an impermeable surface? Well, it's a surface like concrete, asphalt, brick, slate, that doesn't absorb water. Rather, when water falls on any of these hard surfaces, it runs off. It goes straight into the drainage system. Now, if we had more vegetation in our urban environment, vegetation such as what you see in our green roof here, then we could absorb a lot of that surface water. Green roofs act like giant sponges. So around me now, I have 3 boxes. Why do I have these 3 boxes here? Well, these are examples of 2 of the main green roof types. These 2 are extensive green roofs, and this is a semi-intensive green roof. So what's the difference? In essence, the depth of the substrate. So what is a substrate? Well, really, it's an artificial soil. It's an engineered material. And why do we use this material instead of soil? Because it's low density, so it reduces the load on your building roof, and secondly because it's very water absorbent. It's very important during dry conditions that your plant roots can access some water. This is very effective at absorbing water, but then the plant roots can extract water from it during dry conditions. So this is a semi-intensive green roof. Bed thickness is 15 centimetres. All of these green roofs around me though have essentially the same kind of construction. I'm going to show you that now in more detail. So what does a modern engineered green roof comprise? Well, the specifics vary according to the green roof you have. But here at Imperial, this is our basic construction. So imagine this is the top of your substrate. On top of that we have the vegetation. And of course then you have the substrate layer, which is 7 centimetres for the extensive green roof and 15 centimetres for the semi-intensive green roof. Below that, well, we then have a drainage layer. So that's like a series of upturned egg boxes which holds water. So water runs through the substrate and it runs into the drainage layer. It's then possible for some of the water in the drainage layer to be absorbed back up by the plant roots. And to facilitate that, what you may have here is what we call a wicking mat. So a wicking mat is like a carpet in essence, and that allows water to be drawn up from the drainage layer by the means of capillary action. And then below that, well, first of all, you have your root intrusion resistance layer. And then below that, well, you will have a water impermeable layer, which is just to ensure that no water at all, under any circumstances, can access the roof of the building. So what you have here are all the layers that a typical modern, well-engineered green roof will have. As you can see, it provides a lot of protection for your existing building green roof. Equally, it's very well designed to ensure that the plant roots will be well hydrated under different circumstances. Now, another big threat that climate change does pose to cities is an increase in heat waves. Cities have a particular problem with heat waves. Why is that? Well, you can see here, it has lots of hard materials that are very receptive to solar energy. Materials such as brick, such as slate, such as concrete. When they're exposed to warm sunlight, they can absorb up to 95% of the sun's energy, and they heat up, they become hot to touch. And the bigger issue is that actually in the evening, they tend not to cool down very quickly because they have what we call a high thermal mass. Now, because of these issues, a city can be 10 degrees or more warmer than the surrounding countryside on a hot day. And that can make things unbearable. In Paris, in 2003, 15,000 people died due to a major heat wave that happened there. So this is a real issue that we're grappling with. However, there is a way of mitigating the effects of these heat waves. We can use vegetation. Why vegetation? Well, because vegetation, such as what you see here on green roofs, first of all, does not have a high degree of solar receptivity. It does not heat up very rapidly. In fact, some of the sunlight that it does absorb is actually used to drive the photosynthesis process. But moreover, plants want to stay cool. How do they do that? Process of evapotranspiration. Now, evaporation means go from a liquid to a gas. When it does that, it has to absorb localized energy, heat energy. So it's keeping the plant cool, but also it's actually absorbing heat energy from the surrounding environment as well. If you keep your building roof cool, that should therefore reduce the overall temperature of your building. That therefore reduces the need for air conditioning. And air conditioning is a big problem because it's very energy intensive. And of course, most of the energy is being provided in Europe by the burning of fossil fuels. That waste heat is dumped out into the streets, into the surrounding areas. So green roofs are a wonderful way of keeping not only your building cool in the summer, but also the whole city cool. What we're doing here is marrying the latest in modern technology with something that's evolved over hundreds of millions of years, and that is vegetation. Both have a vital role to play in protecting our cities from climate change, in reducing your energy bills, and really enhancing the urban environment, make it a much more attractive, a more pleasant, a more life-enhancing place to live. I just wish to thank Climate KIC, the Transitions Hub, for funding this video, and Climate KIC themselves for making the green roof possible.